g of x and f of x. So with this, we are asked to perform the operation f plus g and then f multiplied by g. And then we find the inverse of f. And after that, we determine that the inverse of f is 1-to-1 or not. Right. So let's not waste much time here. Let's start with our solution. So solution of these questions is going to be, we said that anytime you have ordered pair question and you are asked to perform the operation, look for the domain or look for the input values. In other words, the x values. And we also established the fact that when you have an ordered pair, let's say 3 and 4, the first one, which is 3, becomes what? The x value or the domain. And the y value will be what? 4. This will be the y. That will be 4, or the codomain or the range. Is that okay? So anytime we are going to perform an operation on ordered pair, we should check and look at only those points. The whole of this is a point, okay? So we should look at those points that have the same domain. The points that is having the same domain are compatible. In that matter, we only perform the operations on those points. So looking at our question, we realize that the first point, which the domain is 3, can be matched with this point, right? This point can be matched with this point. We have the domain 1 here can also be matched with this one. Domain 5. Do we have domain 5 in the f function? No. Domain 0. Do you have domain 0 in the f function? No. And domain -1. Do you have domain -1 in the f function? No, this one is -1. So yes, this one. Okay. So we have 3 of them. So now let's go ahead and solve the question. So question 1. F plus G is equal to, the first one that we have is what? 3.3 and 4, and the corresponding one is 3 and 7. So let's add the two of them. Adding, we are going to write only the x value or only the domain because they are the same. So let's write that one. That one is what? 3. And the codomain or the range will be 4 plus 7 because we are doing the addition of the two functions. So 4 plus 7, that will give us what? 11. That will be the first point. And the second point, the domain is 1 and the range will be 4 plus -2. 4 plus -2, that will be what? +2. And the last one will be what? -1. So the domain is -1 and the range will be 5 plus 3, that will give us 8. So this will be the end of the first question. All right, now let's move on to question 2. So question 2 says F times G. And we are going to have the same thing because they have the same domain. So we are going to have 3 and we have 7 times 4. 7 times 4. And we're going to get here to be 28. And then we have this domain to be 1. And then -2 times 4. -2 times 4 will give us -8. And the last one is -1. And then we are going to have 3 times 5 is what? 15. So these are the second solution for the second question. Now let's move on to the next question. Question 3. The inverse of f. The inverse of f. The inverse simply means that you are given the output and you are asked to determine the input. So what we are going to do is we are just going to swap the positions of the x and y values. So in this case, the first point, this point, the input is 1 and the output is 4. So in the inverse, it will swap. So the output becomes what the input. So we are going to have 4. When you input 4, we get what? An output of 1. 2. The second point, we put in 0, we get output of 2. When we put in 7, we get an output of 3. When you put in 1, we get an output of -2. And when we put in 5, we get an output of -1. Is that okay? And the last question. The last question wants to know that if the answer that we got in question 3 is one-to-one function or not. And we said that one-to-one function is when the domain do not have a repetition. When we do not have a repetition in the domain, then we can say that the function is what? One-to-one. Now let's look at the domain. These are the domain. So this is the domain or the x values, okay? The first points in the ordered pair. So we have 4, 0, 7, 1, 5. There's no repetition in the domain. So therefore, we can conclude that the function f inverse is 1-to-1 function. All right, so that will be the end of this question. Now let's look at question 2, whereby we'll be involved with we are going to still look at the operations, and we are going to have combining function. After combining function, we move on to composite function, then inverse function. All right, so quickly, we have a function as f of x to be equal to x squared, and we have g of x to be equal to 1 over x plus 3, right? And we are asked to find or perform some of the operation. So fast forward, f plus g of x is equal to what? So it's the same as f of x plus g of x. Therefore, f of x is x squared plus g of x is what? 1 over x plus 3. And if we can simplify this, we simplify it. If we cannot simplify it, we just leave it this way. Is that okay? And if you are asked to state the domain for this, so the domain of this function is going to be x should not be equal to what? 0. Because the moment x is equal to 0, then the function will be what? Undefined. So at the end, the domain of this function says that x should not be equal to 0. All right, now let's look at the second operation. This is the first one, A. Let's say B is minus f minus g of x. Is going to be the same, f of x minus g of x. Then we are going to have x squared minus 1 over x plus 3. So when we expand the brackets, we are going to multiply through by what? -1. So x squared minus 1 over x minus 3. And at the end, this will be the simplified form of our function. Also, the domain of this function is going to be the same. X should not be equal to what? 0. The next operation that we want to perform is multiplication. So when you have f of g of x is the same as f of x multiplied by g of what? X. And we know f of x to be equal to x squared multiplied by 1 over x plus 3. So with the expansion of this, we are going to get x squared divided by x plus 3x squared. Finding the LCM of this, you are going to have x squared plus 3s cubed, all divided by x. And we can also write this one as x plus 3x squared. So rewrite this one, we have in descending order x squared plus x. And the domain is the same. The domain is the same because x should not be equal to 0. The moment x is equal to 0, the function will be equal to 0. Right. And the last operation, so let's say D. Let's do it up here. So D, when we have f divided by g, okay, of x, is the same as f of x divided by g of what? X. And this can be written as x squared divided by 1 over x plus 3. Now let's try to manipulate or try to turn it around to get the final work to do. But before that, let's find the LCM of the denominator. Let's solve only the denominator first, or the g of x. So g of x is going to be, the denominator for g of x is going to be x. So we are going to have 1 plus 3x, like this, for the denominator. And with a multiplication, if we have a division sign like this, divided by 1 plus 3x divided by x, and we want to make it multiplication. So what we are going to do is, we are going to have x squared multiplied by x divided by 1 plus 3x, right? And then with the multiplication, we are going to get x cubed divided by 1 plus 3x. And that will be the end of this. And then the domain, with this one, the domain is going to be in 2 folds, okay? We are going to look at a number, or a number that will make the numerator to be equal to 0, and a number that will make the denominator to be equal to 0. So in that case, we are going to write that the domain of the function says that x should not be equal to 0 for the numerator, okay? And x should not be equal to negative 1 over 3 for the denominator. And this is going to be what? The domain of this particular function. Now let's limit it down to composite function. Composite function and then inverse function. So with a composite function, assuming we have f of x to be equal to 2x plus 1, g of x to be equal to x minus 1 over 2, right? And then we are asked to find fog. Let's say we are combining it, okay? Fog. So if you're asked to find something like this, fog of inverse, and I told you anytime you have a function like this, please try to expand it. So expanding this, we are going to interchange the place of f and j. So we are going to have the inverse of j should be equal to inverse of j, and or we can also decide to find the f of j and then find the inverse of the answer. Or you can find the inverse separately like this, and then you combine it. You still get the same answer. Right. Now let's do this together, and then we say bye-bye. Okay. So let's do the 2 ways and see if you are going to get the same answer or not. So the first one says fog. Fog of x is the same as f of g of x. Okay. So now, where is our f and where is our g? So we are going to put g of x into what? F. We have 2, and then we place g of x here, x minus 1 divided by 2 plus 1. Now let's expand the brackets. So we are going to have x minus 1 plus 1, because the 2 can cancel this 2. Or we can multiply through, and then we divide also. It's the same. So at the end, you're going to have this to be what? Equal to x. Is that okay? Now let's find the inverse of x. So the inverse of x is going to be what? Now we know we have f of g of x to be equal to x, and we are finding the inverse. So let's try to go through the process. The process says that we should find, or we should let f of g of x to be equal to y. So we are going to have y is equal to x, and then we interchange the value of what? X and y. So we are going to have x is equal to y, and then make y the subject. So we are going to have y is equal to x, and the inverse of this is going to be f of g of x inverse is equal to what? X. Right. Now let's try the other method and see if you're going to get the same answer or not. So the inverse of g is what? We have g of x, so y, the same process. Y is equal to x minus 1 divided by 2. Let's exchange the variables. X is equal to y minus 1 divided by 2. Now let's find y. So we are going to have 2x is equal to y minus 1. Y is equal to 2x plus 1, right? And the inverse of g of x, so the g inverse of x is equal to 2x plus 1. Now let's find the inverse of f. So the inverse of f is going to be y is equal to 2x plus 1, and then we have x is equal to 2y plus 1. Now let's find y. So we are going to have 2y is equal to x minus 1. Y is equal to x minus 1 divided by 2. So the function f inverse is equal to x minus 1 divided by 2. Now, let's put this J inverse of f inverse is the same as J inverse substituted by f inverse of x. Okay? So let's try to put it inside. So J of x is 2, and then we are going to have x minus 1 divided by 2 plus 1, right? Like this. So at the end, this 2 can cancel this 1, and we have x minus 1 plus 1. And this will be what? X. So J inverse of f inverse of x should be equal to x, and this one should be equal to what? Also x. So at the end, we realize that whichever way that you solve it, you get the same answer. So it's up to you to choose which method you want to. Do you want to solve the form and then find the inverse of the answer, or you want to find the inverse of both answer questions and then make the composite function of them together? But if you want to use this method, please take notice of the position of G and what? F. The original function or the original composite, we have F before what? F before G. But if you use the property to expand it, it will be J and then what? F. Please take notice of that.